This is the first lesson using dimensional analysis. Dimensional analysis is a method to change your units on a value. So for example, changing 15 inches to a number of feet. In this day and age, you can look up how to convert known values in Google, but when you get into chemistry, there are stoichiometry problems that you're not going to be able to look up. So it's a method that you're learning to be able to convert and know how much of a substance is in another value. So our learning target for today is I'll be able to convert units using multiple conversion factors in between metric and customary factors. We use units all the time in metric. We have things like centimeters and grams and milliliters and kilometers. Customary, you have things like inches and feet, yards. We have pints and ounces and cups that measure volume. We have pounds and tons that measure weight. So when we do dimensional analysis, we're really working with fractions that are equivalent to 1. So you'll recall that things like 5 divided by 5 are equal to 1. So we're going to write conversion factors in the form of a fraction, because when we multiply anything by a fraction that's equivalent to 1, we know we get the same value. That's something that we've been working with for a very long time in math. So for example, 1 hour is equal to 60 minutes. We can write those conversion factors as fractions. So 1 hour over 60 minutes. And we don't want to just use the numbers. We also need the units. That's the point of this, is that we're not changing the value, we're changing the unit. Or we could use it as 60 minutes over 1 hour. And that would all depend on the units that we're trying to convert and ones that we're trying to get rid of. So each ratio is always going to be equivalent to 1, and the numerator and denominator represent the same amount. We know that 1 hour represents the same amount as 60 minutes. Another one that you might know is we know that 12 inches is equal to 1 foot. That's a conversion that the numerator and denominator represent the same amount. They just have different unit values. So let's start with a real-world problem, because I think that's the best to understand why we do this method. Some owls maintain territories of up to 3 acres. How many owls could live in a large wooded area of 20 hectares? So what we're trying to figure out, and the best way to start these problems, is what do you want in the end? We want to know how many owls. I'm going to highlight that. How many owls? We use a method called railroad method. So we're going to draw a line, and we are going to draw some boxes. And what's happening here is that in one box, that's right here, we have a numerator and we have a denominator. And that numerator and denominator have the same value. For example, 12 inches and 1 foot. What's happening between all these boxes is that we have multiplication going on right here. And we know from past math classes that when we multiply fractions, we multiply across, and then we multiply across the bottom. Another way to think about that is that we would multiply across the top and then divide by every box on the bottom. Division is a form of multiplication. It's the reciprocal of it. So when we solve these problems, when we think about these problems, we always want to know what we want in the end. So we know we want owls in the end. I might give myself a little bit more room than that. We want owls in the end. Okay. And I'm going to draw my railroad, because I know I'm going to have to use that. I don't know how many boxes I'm going to need. I might have to add some. I might not use them all. And then I like to write out what we're going to use. So we do know that some owls maintain up to 3 acres. So we can write that as a conversion factor. So 1 owl is equal to 3 acres. And just like we saw on the previous page, 1 foot is equal to 1 hour, or 1 foot is equal to 12 inches. 1 hour is equal to 60 minutes. We could write this 1 owl to 3 acres as a fraction. We just don't know what we want on top and what we want on the bottom. We also know that we need to convert between acres and hectares. So if we look at our conversion chart that you were given, and on the back side there is a conversion between acres and hectares. So 2.47 acres is equal to 1 hectare. And this is not something I know off the top of my head. This is something I had to look up on my conversion sheet. There are some conversions you should know off the top of your head. How many feet are in a mile? How many minutes are in an hour? How many inches are in a foot? Those kind of things. The things that we use a lot. These uncommon factors, it's okay to have to look them up. So, and then we have the other number here, 20 hectares. So the way that I like to start these problems is, what do I want in the end? I know in the end I want owls. So I find the conversion factor that has owls in it, and I use that to start. Since I want owls on top in the end, I know I need owls on top in the beginning, because that's the only way that they can end up at the top in the end, because when I multiply fractions, I'm multiplying straight across. So, and you'll start to see this pattern. It might seem odd to you now, but as you get through these problems, you'll start to see that whatever we want in the end needs to be on top. So we know we have 1 owl, and that is equal to 3 acres. To get rid of units, we want them to be diagonal. So since we want to get rid of acres, we want that to be diagonal up here to get rid of it. Because you'll recall from other math classes, whatever's on top can be divisible by the bottom, and if there's something on the top and there's something on the bottom, they cross each other out. This is all going to be multiplication. So I'm going to look for something else that has acres in it. Rewrite that. That doesn't really look like, oops. Rewrite this. It doesn't really look like acres very well. The other conversion that I have that has acres in it is right here. So that's 2.47 acres to 1 hectare. And because I have acres on top and because I have acres on the bottom, they cross each other out. So now I have owls on the top and hectares on the bottom. I don't want hectares in my final answer. So I need to get rid of hectares, and the only way to do that is by putting it on top. The only thing I have that has hectares in it is right here, is my 20 hectares. Hectares are on the top, hectares are on the bottom, they cross each other out, and the only thing I have left is my owls. So now, I have some extra space here. I'm just going to erase that to give myself a little bit more room, but you never know how much room you're going to need. So when you solve these problems, or when you calculate these problems, you multiply all the way across the top, and then you divide by the bottom. And we're going to use our calculator the way that it is, as a tool that it is. So on my calculator, I'm going to do 1 times 2.47 times 20. And I'm going to hit enter. I'm not going to write that number down. I'm not going to clear my calculator. I'm just going to hold on to that value, because as we start to get into bigger problems, we might not have as many, we might have a lot of decimals we have to deal with. And then I'm going to divide by each box on the bottom. So divide by 3, divide by 1, and my final answer is 16.467 owls. But that's a weird number. You can't have a partial owl, so my answer will be about 17 owls can take up space in hectares. Let's look at the next one. So I'm going to cross between metric and customary this time. In Europe, gasoline is sold by the liter. Assume that it's that it takes 14 gallons of gasoline to fill a tank of a compact car. How many liters of gasoline will it take? So I'm going to start with my railroad method again. And in the end, I want liters. So I know my final answer is going to be liters. And that means I want to start with liters on top this time. I can look at my conversion factor and I know that 1 liter is equal to 1.057 quarts. Oops, quarts is with a Q. And that's the conversion that gets me from metric to customary. I'm starting with gallons, which is customary, but I need to go to liters. So since I know I want liters in the end, I'm going to start with liters in the beginning. So 1 liter is equal to 1.057 quarts. I want the liters in the end. So I'm going to hold on to that. I can look at my conversion sheet and I can see that 4 quarts is equal to 1 gallon. I'm getting all these from that yellow conversion sheet. I know I want to get rid of quarts, so I'm going to put quarts up top. And I have to go to gallons. So 4 quarts to 1 gallon. My quarts cancel each other out. The numbers do not, just the units. I don't want gallons. I need to get rid of gallons. And in my problem, I actually have the value of 14 gallons. So I'm going to take that 14 gallons and put it right here. And now if I cross those out, because something on top, something on the bottom, and I am left with liters. So I can multiply across the top again. 1 times 4 times 14. I'm holding on to that 56 on my calculator. I'm not writing that down. And then I'm going to divide by each box on the bottom. Divide by 1.057, and then I'm going to divide again by 1. And my number of quarts is 52.980. We're always going to round to the nearest thousandth unless otherwise specified. So let's take a look at rates. Rates are something like miles per hour. How fast you drive. Another way we write that is miles per hour. But we have to be careful with that M, because that M means meters when we're using shortcuts. So I'm going to use my conversion factor, or my railroad method again. I know in the end that I want weeks. So if I read my problem, the Earth is 250,000 miles from the moon. If we travel at a speed of 650 miles per hour, how many weeks will it take to get you there? I want weeks in the end. I have to recognize that weeks is a measurement of time. So the only other time that I have in this problem is hours. So I have to somehow get from hours to weeks, and I need to use the other things in there. So how many miles I am from the moon, how many miles per hour that I'm going, and I might have to use some other conversion factors. So since weeks is a measurement of time and hours is a measurement of time, I can start with that hours on top, because that's what I want in the end. I want time in the end. So if we start with 1 hour over 650 miles. So I want hours, or excuse me, I want time, but I don't want it in a measurement of hours. I want it in a measurement of weeks. So we have to jump from hours to weeks. So how many hours are in one day? You should know that. So 24 hours in one day. And how many days are in a week. So using our logic here to jump from one way to measure to the other. So what happens is my hours cross each other out. My days cross each other out, but I actually have to remember to put that in there. So there are 7 days in 1 week. And what I'm left with is my weeks, which is what I want in the end. But I still have miles, and I don't want any miles. So I need to get rid of miles. The only other thing that I have that's telling me about miles is 250,000 miles. So for me to get rid of miles, they have to be diagonal. So that would be up here. I don't have anything to put that over because I know that I want weeks on top, and I only want weeks. So it's all right when you have a fraction or when you have a number and there's not anything underneath it. How do we make it into a fraction? We just put it over 1. So we have 250,000 miles, and my miles cross each other out. So we multiply across the top. Yes, when you multiply by 1, nothing happens, but I think you should get into the habit of doing it. So 1 times 1 times 1 times 250,000. Make sure you have 4 zeros there. Hit enter or equals. And then you're going to divide across the bottom. So I'm going to divide by 650. I'm going to divide by 24. I'm going to divide by 7. And when I say I'm going to divide, I am actually hitting the division symbol when I do that. You can see the other video that will show that on the calculator. And then I'm going to hit enter. And my answer that I get is I get 2.289. There's a 3 after the 9, so I know it's going to stay like that for the rounding, weeks. So it's going to take me 2.289 weeks to travel from the Earth to the Moon. Let's look at another real-world problem. Mason and his friends drove a distance of 420 miles. The car traveled at a speed of 60 miles per hour. At the time of their trip, gas was $3.65 per gallon, and they estimated they used about 2 gallons per hour. What was the cost for each individual on the trip? So this one's a little trickier. There's quite a bit of conversion factors we have. So actually, let's highlight them. So we have 60 miles per hour. Oh, actually, let's use a better color. 60 miles per hour. We have 5 friends drove a distance. Actually, not 5 friends. How many friends? 6 because of Mason. So 6 friends drove a distance of 620 miles. And maybe you want to make note of that it's actually 6 friends because it's Mason needs to be included in that. At the time of their trip, gas was $3.65 per gallon. And they estimated they used about 2 gallons per hour. And we want the cost for each individual on the trip. So for each person on the trip. So what do we want in the end? In the end, we want the cost per person, per one person. So when we set up this railroad method, what do we want in the end? We want money. So the easiest way to set these problems up when you don't know where to start is to go to what you want in the end. We want money. Which conversion in our problem has money? $3.65. So let's start with that. So we have $3.65 per gallon, per 1 gallon. That's a fraction. So we know we want money. I always like to circle what I want, so I'm not going to get rid of it. But I don't want gallons. I know I need to get rid of gallons, so it goes diagonal. Which conversion factor has something with gallons in it? 2 gallons per hour. So 2 gallons per 1 hour. My gallons are crossing each other out. I don't want hours. I don't want that in the end. It does down here, I have money per person, no hours. So I need to get rid of hours. Where does hours go? Diagonal. What conversion has hours in it? 60 miles per hour. So we have 1 hour and we go 60 miles. My hours cross each other out. But I don't want miles. In the end, I want money over persons. Which conversion factor has people or has miles in it? 6 friends go 420 miles. So I know I don't want miles, so that goes diagonal. So 420 miles and 6 people. My miles cross each other out. I want people or persons in the end, so I have money on top and people in the end. Everything cancels each other out. So now I can do my multiplication. $3.65, so 3.65 times 2 times 1 times 420. Hit enter. I'm leaving that on my calculator. I'm not writing that down. I know that doesn't seem like an issue now, but when we have these crazy decimal problems, it will. And then we're going to divide by each box on the bottom because division is a form of multiplication. So divide by 1, divide by 1, divide by 60, divide by 6, and it should come out to be $8.52 because it's 8.516666 and the 6 keep going, and I'm going to round up because money is rounded to the nearest hundredth. So my final answer is going to be $8.52 per person. That's how much it would cost for each person to go on this trip.